Hello students. In this lecture we will see second numerical on source transformation. So the problem statement is reduce the network shown into a single source and a single resistor. Now in this numerical they are not mentioning which type of source. So we'll give the answer in both the format. Voltage source with the series resistance, this will be the first option, and another option will be current source with a parallel resistance. Now before solving this numerical, if you see here there are 3 voltage sources, 1 current sources and 4 resistances. So which transformation has to be done? So for that we have to develop a strategy. Taking this diagram and doing a rough work over here. Now in this rough work, what we have to do? You have to remove the voltage source by short. We have to replace voltage source by short circuit and current source by open circuit. So let us replace this voltage source by short circuit and current source by open circuit. So I replace these two sources, I have removed these two sources and there won't be any current source over here. Current source has to be replaced by open circuit because the internal resistance of the voltage source is, ideal voltage source is 0 while that of a current source is infinite. So this is the resulting circuit diagram. And now you can think like that. You have to calculate the equivalent resistance between A and B. So if you have to calculate equivalent resistance between A and B, then what you will do, the first step will be this 2 ohm and this 2 ohm, they will be in parallel. Similarly, this 3 ohm and this 1 ohm which is connected over here and one end towards B, they are also in parallel. And then you have, let's say if you have to solve this thing, then you will have a circuit like this A. Let's say this node is M. So M, you will have one resistance. I am not interested in the value of the resistance right now because I am building a strategy over here. And between M and B, another resistance will be over here. So now these two resistances are in series. So this will be the final answer. What it says that when you are taking 2 and 2 in parallel, that I want current source over here, I want current source over here. This 3 and 1, they are in parallel, that means again I want current source to be present over here and current source to be present over here. Then I will combine these two current sources, I will combine these two current sources and finally I will require a voltage source and voltage source over here so that I can add this. So first thing is I want current sources to be present in all the 4 branches. So we'll coming back to our numerical. So here current source is already mentioned, so we'll not go for the transformation of this one. Rather we'll go transformation of these 3 voltage sources with a series resistance into equivalent current source and parallel resistance. So how to do this thing? So you will have 2 ohm resistance as it is, this 1 ampere moving upward as it is. So there is no problem for this one. This is 1 ampere. Over here I will have 2 ohm resistance and a current source will be moving upward. I am talking about this branch. Current source will be moving, will have direction upward. And what will be the value of current source? So 4 by 2, that is 2 ampere moving upward. This is terminal A. Then from this end I will have 3 ohm resistor and there will be a current source which will be moving downward towards B. 6 by 3, the value of this current source is 2 ampere. Here I will have 1 ohm resistor and the value of the current will be 3 by 1, that is 3 ampere, but the current will be moving upward because 3 volt positive is connected towards M. You can say this is terminal M. So M is over here while negative is connected to B. So next diagram will be, you have to go on drawing the diagram after each and every step. So these 2 and 2, they are in parallel and in parallel combination I will have equivalence as 1 ohm resistance. One end is connected to A. This 1 ampere is connected between M and A. This is 2 ampere again connected between M and A. So you can combine those two current sources. Both the current sources are moving up, currents are moving upward. So the resultant current will be moving upward and the value of this current source will be 2 plus 1, that is 3 ampere. In the lower part of the circuit from M to B, this is M, okay, from M to B, I have 3 and 1, they are in parallel So the equivalent resistance will be 3 and 1, they are in parallel. So product by sum, so 3 by 4, so that is 0.75 ohm. This 1 ohm is because of 2 parallel with 2. Current source, 2 ampere moving downward, 3 ampere moving upward, 2 ampere moving downward, 3 ampere moving upward between M and B, and these current sources are connected in parallel. So the net current will be 1 ampere going upward, because we have to follow the direction of the bigger current source when they are connected in parallel and opposite in direction. So after this, again if you build a strategy over here, you remove current source over here, you remove current source over here, and then 1 and this 0.75 ohm, that means this resistance 1 ohm and 0.75 ohm, they are connected in series, and for series connection I prefer voltage sources over there. So are there voltage sources present over here? No. So again you have to go for the source transformation. So the next step will be, there will be terminal A, you will have 1 ohm resistance, and you will do a conversion of this one, and this will give me 3 volt over here. Why 3 volt? Because I into R, I will get 3 volt. I have reached point M. Then you will do the transformation of this one. So the resistance value will remain same, that is okay, I forgot to mention the value of resistance over here. Here it is 1 ohm and here it is 0.75 ohm. The voltage source will have positive polarity towards M while negative polarity towards B, because current is moving away from B. Value of this voltage source is 1 into 0.75, so that will turn out to be again 0.75 volt. So you can see here from A to B you have a just one series connection. So final answer will be there, where this 1 ohm and 0.75 ohm, they are connected in series. You can combine them and I will have 1.75 ohm resistance between A. And if you talk about the polar voltage sources, 3 volt positive towards A, again 0.75 volt positive towards A. So they are known as series aiding. The connection is known as series aiding, and you can add them and it will become 3.75 volt, and this is terminal B. So this is the one of the possible answer. Okay, you can say answer 1, because in this numerical they have not mentioned which type of source and resistor. So last transformation we will do and we will get second answer, possible answer, where you will have a current source and a parallel resistance. The value of the resistance will remain same, that is 1.75 ohm, and current source will be moving upward, and the value of that current source is 3.75 divided by 1.75. So it turns out to be 2.143 ampere. So this turns out to be 2.143 ampere. So there are two answers possible for this numerical. What I suggest, first of all, you build a strategy by removing the current source, or rather making current source open circuited and short circuiting the voltage source, and then you calculate equivalent resistance between A and B. You note down what is the process. If there is a parallel connection, you prefer current sources to be in those branches, and then if series connection is there, you prefer voltage sources to be there. And then similarly you can go for the source transformation at every step and you can finish the thing. Thank you.